Many project managers know these words here: requirements, testing, deployment, production. But the scary part, many project managers can recite the phases of the SDLC, which is software development lifecycle, and still struggle to lead software projects successfully. They understand the phases. They don't understand that what's actually happening inside of the phases. But today, we're going to unpack that. So let's jump into it so we can get a better understanding. I don't care if you're a project manager, scrum master, CAPM credentials, PMP candidate, or if you're just someone that's just really trying to break in the industry, family, this is something that is going to be valuable for you, because if you've ever led a team of a software team where it comes with API, data integration, mobile applications, just websites and reporting platforms, and now more than ever is AI solutions. You want to make sure that you have a better understanding of what we're talking about here today. So with no further ado, I'm going to jump into this SDLC and hopefully you'll understand it. And I'm going to put it if I was coaching or training someone to understand SDLC, this is exactly how I would explain it to them. All right, let's get into it. Phase one, planning. When we look at planning, we want to understand what we're establishing. Is it, comes with our project charter, budgets, risk, stakeholder timelines, but we want to ask key questions. Some of those key questions is, hey, what are we doing here? What problem are we trying to solve? What business outcome are we trying to achieve? And how much will it cost? And how long will it take? And then most importantly, what risk do we already see? See, most projects don't fail during the deployment, or I should say during the development. They fail before the development actually starts. So without planning, you're just moving fast in the wrong direction. Here's my professional advice about this, family. The biggest mistake I see project managers make around software projects is believing their job is to manage the schedule. Your job is not to manage the schedule. Your job is to manage understanding of stakeholders, understanding the goal, the developers understanding the requirement, testers understanding the expected outcome, leadership understanding the risk. See, when everyone understands their piece, the schedule takes care of itself. Isn't that amazing? Because normally we're so focused, we can get so caught in the weeds and focus on the schedule that we can lose perspective of our stakeholders. We can lose perspective of our developers. We can lose perspective of testers as well as leadership. Phase two, requirements gathering. See, there are project managers that for them, they don't understand the value here, because this is where you make your money at. This is where you earn your paycheck, because people rarely tell you what they actually need. They always tell you what they think they need. I need a dashboard. No, you need visibility. Oh, I need a mobile app. No, you actually need customers to access information remotely. See, this phase includes business requirements, functional requirements, non-functional requirements, user stories, and acceptance criteria. What type of questions do we ask in these moments? Who will use this? What problem are we solving? What happens if this fails? And how will we measure success? Phase number three, design. This is when the architects and technical leads begin to design the solution. This is where the question is, what is your technology stack? Because we need to understand the application architect, the databases, the front end, the back end, and the cloud platforms. From an application standpoint, we have monolithic architect. We have microservices architect. We have event-driven architect. Now, when you look at databases, you have your Microsoft SQL Server, MySQL, or the PostgreSQL, Oracle, or MongoDB. Now, front end, this is your React or your Angular or your Vue. Then you have HTML, CSS, and JavaScript. Let me park here real quick, family. From a database standpoint, I've always worked with either Oracle or Microsoft SQL Server. From a front end, it's been HTML or CSS and JavaScript. From a back end, This is where you got your .NET, your Java, your Spring Boot, and Node. JS or Python or C Sharp. I've worked in C Sharp and Python. Now, when I say worked in, meaning I worked with the technical team that was the developers and architects to basically, this is what they worked in to actually build a solution. So what are the cloud platforms? You have AWS, this is the Amazon product, Microsoft Azure, or Google Cloud Platform. Phase number 4, development. This is when the code gets written. Developers begin building the actual solution. And where many project managers, that'll be myself, feels like we've been excluded from this moment because it's out of our depth. But we just need to have a general scope of what they're actually looking to do. UI or user interface. This is the visual layer where users get to interact directly. You have your API. This is what bridges to connect systems and services. And I'm going to give you something to help you understand APIs a little bit better from a very just how I was taught to learn with APIs. So if you stay to the end, I got something for you there. Then I have business logic. This is where rules are driven by how application behaves. Then you have your databases. This is just where your storage for your application data is. And then security, which is very important. So your security controls, protecting data and access at every layer. And then integration, connecting with external platforms and tools. Again, you do not need to be a developer, but you should understand what the team is actually building. Phase number 5, this is testing, because listen, just because the code work doesn't mean that it's actually working to support the application. So we're going to do unit testing. So basically how this works, developers test individual pieces of the code in isolation just to verify the code is working as expected. Then we have integration testing. This is testing where systems and components communicate correctly to each other. Then we have system testing. This is again where we're testing the entire application from end to end as a complete unified system. And then UAT. This is where the business users verify, does this solve my problem? Now, I want to say something because I've seen this happen as well, where the UA testing will be done by the same people that were doing the other testing, which is fine, but it's not fine. What do you mean, ED? What I mean by that is that you want to ensure that the business is part of the process. So if you're working let's say you're working with accounting and you need to get a sign off, you need to get a guarantee that someone in accounting that's actually going to be the one using the software, that they're going to be part of this whole UAT, because if not, you won't be able to see what they see. They'll be able to see some gaps that maybe you may not see because you're close to it, number one. And number two, they're the ones that are going to be using the product. So project managers' role in this whole testing is test plans, test execution, defect tracking, and sign off. One of the things, again, I always want to point out to you, defect tracking is very important. And most of all, you want to get a sign off of approval when testing is complete. Phase number 6, this is the deployment. The software moves into production. The deployment is not just a technical event, it is a coordinated organizational effort. This is when you really come in and shine. So what are those activities look like for deployment? Well, we got production release, change management, user training, support readiness, and release communication. You want to over communicate as much as you can. Let's look at 6 phases. You have your common environments, your development, your test, your QA, your staging, and production. One of the questions I put here, because I want you to ask this question, is how do you manage risk during deployment? If the response is we have a rollback plan, if the response is not, we have release checks, if the response is not production validation or stakeholder communication, what I'm saying there, these are big components of deployment. We need to have a rollback plan. We need to have a release checklist. We need to have a production validation, and we need that stakeholder communication. Phase number 7, maintenance and support. This is where most software spends more time than any, because we need to be able to identify any defects that needs to be discovered after go live. So any bug fixes, security update, any patching, any vulnerabilities, just to make sure we can keep the system protected. Performance improvements. How do we optimize for speed, reliability, and scalability over time? Any feature enhancement based on user feedback or business need, and then technical debt reduction. If you ever study anything around agile, you understand about technical debt. This is where we're going to refactor and clean up code to keep the system healthy long term. This is where it's so important because I've seen it where sometimes teams think this as an afterthought as far as continuous improvement instead of an ongoing investment. We want to ensure that this is an ongoing investment for maintenance and support. So, three things every project manager should understand about SDLC. You don't need to code. You need to understand how software gets delivered. Your value is coordination, communication, and clarity, not in writing code. Number two, requirements problems become development problems. The earlier you identify ambiguity, the cheaper it is to fix. A vague requirement costs 10 times as more to fix in development than in actual planning. And then the biggest thing, you know, our motto here, documentation over conversation. So we want to make sure we have a good communication as a bridge. The best project managers translate in both directions, from the business to the technology and from technology back to the business. What is an API? So API stands for application programming interface. I want you to think of API. Here's a good analogy. API is like a waiter in a restaurant. So you place an order. Think of that as like your customer app makes a request. Waiter takes the request. So now that means like your API is carrying the request to the kitchen, basically like a server. Then step three is the kitchen prepares the food. So I want you to think of the system processes and retrieves the data. And then number four, response delivered back. This is just like the customer sees the results. So examples would be like your banking information, a banking app, or anything like that. I'll use the banking because that's easy to understand. If you have your banking app, log in, you send in a request like to log in, it verifies your details, and then it comes back to you. So real world API examples: Salesforce API, Stripe API, Google Maps API, Microsoft Graph API, and then Workday API. See, without APIs, applications can't communicate. Systems remain isolated and data sharing becomes manual. Well, family, I hope you enjoyed today's episode about SDLC, software development lifecycle. What's important that I want you to remember are those 3 points that I shared with you. Again, you don't need to code. You need to understand how software gets delivered. Your value is in coordination, communication, clarity, and not in writing. And the second thing, requirements problems become development problems. This is key because if you can identify ambiguity, it is cheaper to fix versus a requirement that may cost 10x to fix in development than in planning. And the last and final thing here is communication is the bridge. The best project managers translate in both directions, from business to technology and from technology back to business. If you're new to the episode, I go by the name of ED. For all you smart and intelligent folks out there, that just simply means there. Until next time.